YouTube. In my last couple of videos we've been discussing both numerical and variable expressions, and so kind of the reason behind all this is so that we can get into some real life type of application situations which we can write verbal models, okay? And this is what everybody kind of knows is the dreaded word problem, okay? But in this video we're going to confront how you can do so kind of in a standard manner, so that it's less intimidating and more formal, okay? But we say we're modeling real life situations algebraically all the time. So we say any expression that represents a real life situation, we're going to call this a mathematical model, okay? Because the mathematical model is kind of a quote-unquote predictor for what we think would happen in a real life situation. It's not actually going to happen that way. It's more of a theoretical kind of thing. We think it'll happen that way. But when we create expressions, we're modeling that real life situation, and we always kind of follow this order. And the first thing we always kind of do is this: we understand the situation. We write a verbal model. So when we talk about a verbal model, okay, we say this is in words. So of course it's a verbal model. Let's be clear on this. It's going to include words, but we say written in phrases. And I want to be clear on this one also, but we say phrases, these can be short. So it's short and it's in words, and I'm going to kind of write it this way: it is a plan. All right, and it's kind of a plan of action how you would calculate something given a situation. All right. Once we have the words, though, the nice thing is we can just come up with symbols for those words. So like in the last video I said height. If we use the word height, we could replace it with the variable symbol h. Because variables are letters. It kind of allows us to shorten the sentence a little bit from our verbal model down to a symbolic model. Okay, and then last but not least, what we're going to do is we're going to list all the values that we know, and we're going to plug those in. We're going to evaluate and find a value, typically a value that we're looking for in the first place. But this is kind of our four-step formal model for doing these. So let's go ahead and take a look at these two models that I put up here, or these two situations, and we're going to model them algebraically and kind of see what we can figure out. But it says this: write verbal models for the following situations and then find the desired values. Okay, so we'll start with A here. It says we have $250 to spend on gas. One good thing as you read through this to do is kind of underline important values. So we say $250 to spend on gas. We say each tank of gas usually requires about $40 per tank. So $40 per tank to fill up. We say write an expression that shows how much money we have left after buying N tanks of gas. So you see we've already got a variable value that we've been asked to use here. It says then find how much money is left if they purchase 2.75 tanks of gas. Okay, so I want to kind of put this in a different color here. When this says find how much money is left if they purchase 2.75 tanks of gas, this is kind of like an evaluation situation. And the reason why is because what they've done is they're saying after you've got your model, I want you to evaluate given this particular value for this variable. Okay, and we're going to use units when we do this. So we say start with this: write a verbal model. If you had $250 to spend on gas, like say for the month, okay, and you knew that each tank of gas was about $40 to fill up, could we come up with an expression that shows how much money we have left after buying N tanks of gas? Okay, so how much money you would have left as a function of like how many tanks that you purchased. Okay, so let's write down what we know. First of all, we have $250 to spend on gas, and if we want to write an expression that represents the amount of money I have left, it's going to be, say, the starting amount minus what I kind of spend. Okay, so we say starting amount. I'm just going to write this in words. Starting amount, which is our $250 minus what I spend, is kind of the amount left. All right. Now, I'm kind of not far enough along yet to write this particularly as an algebraic expression yet on the left, but we're going to kind of go further into this. We say, well, how much do I spend? We said, well, it depends upon how many tanks of gas you buy. Let's talk about this honestly. And we say N is the value that we're using to represent tanks of gas, but we're going to kind of write it out first. We say, all right, it'd be the starting amount, okay, technically, minus, now when I say spend, how much do I spend? Well, it depends. How many tanks of gas did I buy? And if I wanted to say, well, what if I bought one tank of gas? It'd be $40. What if I bought two tanks of gas? It'd be, $80. Three tanks of gas, $120. Or the number of tanks I buy times the price per tank. Okay, so we say it'd be price per tank times the number of tanks. Okay, and what I want to recognize here is this: all I did was kind of reason this out in my head and wrote down a plan. Okay, this was this is our plan, is our verbal model. Now we're going to throw in variable values. So when we say the starting amount here, okay, we say do we know the starting amount? Is this a variable value or was this a fixed value? And we know that this was $250. So we're going to rewrite this symbolically, and we're going to plug in what we know. So we say $250 So this would be $250 minus the price per tank. Now, do we know the price per tank? You know, we say, well, we knew the price per tank was $40. So this would be $40 is now going to go in for this value here. Actually, technically, I should be putting in blank parentheses. Okay, and it should look like this. And we say, okay, well, number of tanks, we're going to call this N. There's our value N from over here. And we say, last but not least, we say the amount I have left. And if I don't know what the amount I have left is, you know, it's some changing value, we could refer to this as some amount. We'll call it A. But right here, what we're going to say is this is our algebraic model. And it's now become an algebraic model from our verbal model because we plugged in variables for our, you know, verbal things. Okay, so now what we wanted to do is this very last thing down here is evaluate. It says, well, how much money would you have left if you purchased 2 3/4 tanks of gas? And so what this is, this 2 3/4 tanks of gas, is this an amount or is this a number of tanks? And so we say it's a number of tanks. So really what they've done is they've given us an N value here, 2.75, and this is tanks. And we want to make sure we write units. So we say, well, if that's the case, let's go ahead and evaluate this expression on the left for this. We say this would be 250 minus 40 times 2.75. This would be the amount we have remaining. And of course, you know, there's nothing wrong with doing this on a calculator. In terms of, you know, evaluating this expression on the left, we have to do our multiplication first. So we say 40 times 2.75. We'd have 40 times 2.75 was 110. So now we say this is the same thing as 250 minus 110 is the remaining amount, and 250 minus 110 is going to leave us with $140. Okay, and we want to make sure that we label this. So this is $140 remaining after getting 2.75 tanks of gas, and of course I'd write that out as a complete sentence. Okay, but for now I'm going to move on to this next example. This last example says a person has a special phone plan that costs a set monthly fee of $50 plus $0.06 per minute. Okay, so we need to underline these. We say set amount $50 plus 6 cents per minute. It says write a model to show how much the person owes for their monthly bill if they talk on the phone for M minutes. Okay, and it says then, you know, this is our alternate sentence down at the bottom. It says then find out how much it'd be if they talked on the phone for this many minutes. Okay, use units. So we say, all right, phone plan. Let's think about this. If you had a phone plan, you spent $50 plus 6 cents per minute. To find out your amount that you owed, you'd have to say, well, it'd be the original 50, and then you'd have to add on how many minutes I talk times 6 cents a minute. So our verbal model is going to look like this. The amount that I owe is equal to, we'd say the price per minute multiplied by the number of minutes. Okay, and so now we're going to pick this apart. Again, we're going to say, let's do variable values. We say the amount, let's use A. We say is equal to, well, this would be equal. The price per minute, okay, so we have price per minute multiplied by the number of minutes. And we say the number of minutes, we're going to use M. And then we'd say, okay, plus the, oh, we forgot about this, equal to the price per minute multiplied by the number of minutes plus the initial amount. So this means also that we have to add on the initial $50, okay? So now we're going to kind of simplify this further. We say the amount that I have is equal to the price per minute. We know the price per minute would be $0.06 per minute times the number of minutes plus 50. So now, last but not least, it says, okay, how much is the bill going to be if they talk on the phone for 121.8 minutes? Now, is this an amount or minutes? We say this is a minute. So we're going to plug this in and evaluate. We plug this in here, and so we would get this expression on the right. The amount would be equal to 0.06. Oops. Let's go ahead and say 0.06. Try again. Times number of minutes. We have 121.8 minutes plus $50. And we say this is dollars per minute. Okay, so we say, well, our minutes would cancel out here, and we have dollars times this scalar here, this number. Okay, we say 0.06 times 121.8. Okay, and then we'd say plus 50. So the bill would be 57.308. So we say 57.308, and this was in So that's how we kind of write and evaluate verbal models. Cheers.